Hello, Hello, Excel Geo. We are on 10.7, day 2, which is a continuation of equations of circles. Now, as we move forward with the equation of circles, I just want to make sure that we review that our standard form of our equation is x minus h quantity squared plus y minus k quantity squared is equivalent to r squared, where hk is the center of our circle and r is our radius. Okay, we're just going to recall that. So let's just go through an example again. If you want to, you can try this on your own before you watch the video, or you can follow along with me, whatever you're more comfortable doing. So today we're given 2 points again. We're given P is 2, 6, and Q is 8, -4. And they are the endpoints of my diameter of the circle. And what they're asking us to do is to find the center. So we're trying to find our HK values. If you're given 2 endpoints of a diameter, you will know that the center has to be the midpoint of that diameter, because the diameter is consisting of two radii, and it must intersect the center. So if I want to find the center, and I'm going to label my center C in this case, if I want to find my center, I'm going to find the average of my x values, so I'm going to add my 2x values up and divide it by 2, and the average of my y values, which is our midpoint formula. And if I simplify that, I'm going to get 10 over 2, which is 5, and positive 2 over 2, which is 1. So what we have here is a value, we're going to label it C for our center, of 5, 1. That would be my center of my circle. Excellent. Now, the other thing that's important when we write the equation is the center and the radius. Now, right now, there's 2 ways you can find the radius in an example. You can use the 2 points you're given, P and Q, find the length of the diameter and divide it by 2. Or what we can do is we can say, well, I now know my center is 5, -1. I'm going to take my center and one of those points. And the point I'm picking is P, because I'm dealing with smaller numbers, and they're both positive. If I take that center and P, if I find the distance between the two, I will then know the radius. So the radius would be equivalent to the square root of, let's do our distance formula, 5 minus 2 quantity squared plus 1 minus 6 quantity squared. All right, guys? So now let's take a look at this. If I look at this, 5 minus 2, I'm getting square root of 9. 5 minus 2 is 3. 3 squared is 9. Plus 1 minus 6 is -5. The quantity of -5 squared would be 25. So my radius would be equivalent to the square root of 34. And guys, I'm going to leave it there. And the reason I'm going to leave it there is because it is 34 does not have a perfect square factor, so I cannot simplify it. And I like having it in radical form because I'm not rounding it. I'm getting an exact answer, leaving it as the square root of 34. And when I go to the next part, part C, where it says, write the equation of the circle in standard form, I can easily get rid of the radical when I substitute it in for r squared. So if I want to write this equation in standard form, I'm doing x minus h. Well, h is the x value of my center, which is 5 quantity squared, plus y minus k. K is the y value of my center, so minus 1 quantity squared, would equal the radius squared, which is the square root of 34 squared. But squaring and taking the square root are inverse operations, so they cancel each other out. So your equation would just be x minus 5 squared plus y minus 1 quantity squared is equivalent to 34. That would be the equation of my circle. Okay? Now let's take a look. It says graph the circle on a coordinate plane. And we talked about this yesterday. We talked about how to graph a circle. And radius of square root of 34 is a little tricky. What is that approximately? Well, I know the square root of 25 is 5. And 34 would have to be greater than that. And I know the square root of 36 is 6. So that means the square root of 34 would have to be somewhere between 5 and 6. But since 35 is closer to 36, I'm going to put my dot closer to 6 units away. So first I say this is what their radius. I'm talking about my radius here. And that's going to help me find what we called our crosshair points. Right, guys? Yesterday we took a look at it and we said, how can we find our crosshair points? Now, our crosshair points are just, we use it because it looks like a cross. All right? So the first thing I'm going to do is I have 5 and 1. So I go 1, 2, 3, 4, 5, and 1. That's C. That is my center. Now, your crosshair points, remember, your crosshair points, we just make a cross. We go right, up, left, down, and we move the length of our radius. Well, I know the square root of 34, I mean, we're estimating here because we can't exactly get that value on a coordinate plane, but we can make an educated guess that square root of 34 will be closer to 6 than 5 because 34 is closer to 36. So if I take a look at this, I can count over 1, 2, 3, 4, 5, and then put it between 5 and 6, but go closer to 36. I'm sorry, closer to 6. Now let's do the same going up. 1, 2, 3, 4, 5, and I'm going to make it between 5 and 6, but closer to 6 units away. Count again. 1, 2, 3, 4, 5. I'm going to make it closer to 6 units away than 5, but between 5 and 6. And down. 1, 2, 3, 4, 5, and again closer to 6. That same concept. Now, right now, I can just do the best I can. You know, I'm not great at drawing circles without my Promethean board. But draw the best circle you possibly can. So that is circle C. Okay, and we have our crosshair points, and we have 4 of them that make a cross. It's 1, 2, 3, 4. It looks like a cross. That's why we're calling them crosshair points. Now, what it says next is it says, give equations for the 2 horizontal tangent lines and the 2 vertical tangent lines to this circle. Well, how are we going to do that? So let's take a look. This is how we're going to do that. We're thinking of a tangent line. A tangent line only intersects a circle at a point of tangency. Now, that means it can only hit the circle at one point. If I'm looking for 2 horizontal tangent lines, I need 2 horizontal lines. If I think of a horizontal line is y equals a constant value, because on a horizontal line, the y value remains constant. So if I'm having a horizontal line, I can put 1 above the circle that's tangent. That's going to hit this crosshair point. That wasn't very horizontal. That was a poor horizontal line, but right about here. Let me straighten out. Sorry, guys. All right, so 1 on the top, that's horizontal, and I can put 1 on the bottom that's horizontal, right? And if we take a look at them, they're crossing these points. Now, I'm going to actually label these points so we can figure them out. So like, for example, I can label this X, Y, Z, and W. Those are our crosshair points. Now, I need to somehow find, if these are horizontal, the Y value up here. How do I find the Y value up here for these horizontal lines? Well, I moved up what? I didn't move up 5, I didn't move up 6, I moved up square root of 34. So if we think of these points, let's think of Y and W. Okay, so let's look at Y first. If I moved up that value from the center, I moved up the square root of 34 from the center. If I move up, that affects my Y value. So the point Y would be 5, the X value would remain the same as the center, and then I'd have the Y value of 1 plus square root of 34, because that's what I moved up. And the same notion, if I look at W, I didn't move up square root of 34, I moved down. So then my X value is still 5, because it was at the center. I just moved down. I moved down root 32. So it would be that one value of Y minus the root 34. So that there, if I look at it, they would be my 2 horizontal tangents. Right there, I have my 2 horizontal tangents. Right, and I got them from here. Now let's take a look at our next thing that we're going to talk about. We're going to talk about the vertical tangents. Now vertical, again, vertical lines are going to be slightly different. Instead of saying y equals, we're going to say x equals. So the vertical tangents will, again, intersect our circle at one point, but it's going to be a vertical tangent on the right and on the left side of those circles. And so those are my vertical tangents. Now if I take a look at them, so I'm looking at the right and the lefts of my circles. Now, if I look at them, how did I get those crosshair points, x and z? Now, because remember, in a vertical line, the x value stays constant. So our equation of a vertical line is x equals something. So whatever the x values is at point x and point z will be the same x value for the entire vertical line. So if I look at point x, all right, guys, I'm looking at point x. To get from the center to point x, I added square root of 34 to my x value. If I move to the right, I'm adding the square root of 34 to my x value. So it's 5 plus square root of 34, and then my y value remains the same. And the same thing, if I'm going from the center to z, I subtracted square root of 34 from my x value. So it's 5 minus the square root of 34, and my y value stays the same as 1. So my equation would be x equals 5 plus the square root of 34, and my other equation would have been 5 minus the square root of 34. And that's how I get my two vertical tangents. All right, guys? All right, guys, let's look at our last page of day 7 notes. All right. Okay, I think it's underneath here. Let's see. Yep, right underneath. Okay, our second page and our last page of 10.7 notes. All right, guys, let's see if I have, just make sure everything is straightened. There. All right, guys, I think we are good. All right, guys, so let's take a look at this. If we take a look at this, we are going to, given the center of the circle, we're given another circle. We have negative 5, 3, and a radius of 13. All right, guys? So, write an equation of the circle in standard form. Again, just x. Now, you're subtracting the x value of your center. But if I'm subtracting a negative 5, that's going to be x plus 5 squared plus y. I'm subtracting my k, which is 3, y minus 3 squared would equal my radius squared, so that would have to equal 169. All right? Now, the next thing they're asking us is for the 4 crosshair points. Now, guys, we talked about this. If I have my center, and I'm going, in this case, negative 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. This is my center, and I'm going to do C again, just C for center to make it easier. Now, if I'm doing crosshair points, I'm making a cross, and that's what we talked about. We're making a cross. We're going right, up, left, down. Now, let's think about this. If I have C, and I'm traveling to the right 13 units, when I move to the right, I'm affecting the x value. So if my center has a negative 5, if I add to that negative 5, we're going to label this R. If I add 13, which is the radius to my negative 5, I will be getting 8, 3. And you count over, see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That point there, R, is at 8, 3. All right, now if I go, in this case, if I do S, I'm going to count up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If I'm counting up 13, I am going to affect my Y value. So then S would have the same X value as my center, but I would add 13 to my Y value, so 3 plus 13 would be 16. Okay, let's find another crosshair point, T. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I went left 13 from the center. Again, if I'm moving left, that's affecting my X value. It's affecting my X value, and because of the direction I'm moving to the left, I'm going to subtract from the X value of my center. Negative 5 minus 13 would be negative 18, and the Y value stays the same. Now my last one I'm going to do is U. I'm going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have U there. Now, if I'm going down, that's affecting the y value of my center. So I'm subtracting 13 from y. So I have negative 5, my x value would stay the same. So I have 3 minus 13, which would be a negative 10. Those, and we just call them crosshair points because when we connect them, it looks like a cross. Excellent. All right. Now it's saying, now if I can kind of try to draw the best circle I can. And again, it's not going to be perfect. All right, guys, so if we take a look at this. Now, this says find the points on the circle that correspond with x equals 4. And we did do this yesterday. Now, if you take a look at this, I want to draw a horizontal line x equals 4. So if I go, I want to draw a vertical line for x equals 4. 1, 2, 3, 4. And go to 4, and I draw this vertical line. This vertical line will represent the line x equals 4. What you'll notice is that line intersects that circle at 2 points. All right? Now, those 2 points will be when x is equivalent to 4 at that circle. So you should get 2 y values out when we solve it. So now if I plug this in, and I have my formula, I have 4 plus 5 squared plus y minus 3 squared equals 169. Now, if I take a look at that, I get 4 plus 5 is 9. 9 squared is 81, plus y minus 3 squared equals 169. If I now, when I take another look at that, if I subtract, I'm getting y minus 3 squared equals 88. Now, we continue to solve, we need to take the square root. Now, because we have 2 solutions here, when we take the square root, you're getting y minus 3 equals the positive and negative square root of 88. I'm going to add that 3 to the other side now, and be careful, I have that plus or minus. The square root of 88 has a perfect square factor of 4. I can pull out, square root of 4 is 2. If I divide 88 by 4, when I pull it out, I get 22. Now I have 2 values of y, which makes sense because I have 2 points where x is 4. I have the point 4, comma, 3 plus 2 root 22. And I have the point 4, comma, 3 minus 2 root 22. Those are the 2 times where x is equivalent to 4. Now, if you look at your next problem, they're asking when y is equivalent to negative 8. Now, similar, this is slightly different. X equals 4 is a vertical line. Y equals negative 8 is a horizontal. So I go 1, 2, 3, 4, 5, 6, 7, 8, and I draw a horizontal line. Now, if I look at that horizontal line for y equals 8, negative 8, I again see that it intersects at 2 points. Therefore, I'm going to have 2 solutions here. So if I take a look at this, my first solution, I'm going to have x plus 5 quantity squared plus, what's going in for y? Negative 8, right? So it's negative 8 minus 3 quantity squared, and that's going to equal 169. Now, if I solve this, I'm getting x plus 5 squared plus negative 11 squared, so the quantity of negative 11 squared is 121, equals 169. If I continue to solve this, I get x plus 5 quantity squared is equivalent to 48. So again, when we take the square root, we take the positive and negative square root of 48. We're going to move that 5 over, negative 5 plus or minus. 48 has a perfect square factor of 16. 16 goes into 48 3 times. So you're going to pull out the 16, the square root of 16 is 4, and then you have a 3 remaining. So that's the 2x values for these 2 points here. So that means your 2 points, if I take a look at it, would be, your 2 points would be x minus 5, your 2 points would be negative 5 plus 4 root 3, comma negative 8, and negative 5 minus 4 root 3, comma, negative 8. So those would be your two values there. All right, guys, so now we're going on to E. And part E says, what if I substitute x equals 10 into the equation? Look what happens here, guys. If I substitute x equals 10 into the equation, explain the results. So if I do 10 for x plus 5 squared plus y minus 3 squared equals 169. You take a look at that. 10 plus 5 is 15. 15 squared is 225 plus y minus 3 squared equals 169. When I move that 225 over to the other side, I'm getting a negative 56. I'm sorry, negative 54, right? Oh, no. No, we're good. So if I take a look at that, if I have this negative 56, now what we have here, then we're going to take our square root. We have y minus 3 equals the positive negative square root of negative 56. Now, just so you're aware, guys, when we take a look at this, I have a negative under the radical. We are in Euclidean geometry. We do not have imaginary solutions. So we have no solutions. Now, someone pointed out yesterday and during my conference that should we write no real solutions? It's really no solutions. In this case, you can write because we're in Euclidean geometry, we're only working with the real number system. But you're also obviously can write no. The double R represents real solutions. All right, guys? Because in this case, we do not have a real solution, but just be aware that the Euclidean geometry system only works with real numbers, so we don't have to address imaginary numbers in this, in our course. All right, guys? Now, the next thing we have is our last one, which is F, which talks about, I just want to make sure we can see this one. All right, I think we can see it well. I hope we can. Now, guys, if we take a look at this, it says, given that 5, 12, and 13 is a Pythagorean triple, find 8 more lattice points on the circle. Now, I realized when someone asked a question on my conference that I really didn't emphasize what lattice points are. Lattice points are points on a circle that have integer x and y values. So that means everything that has integer x and y values. Now, our 4 crosshair points are lattice points. So these 4 crosshair points are lattice points. But right down here it says 8 more lattice points. That means we don't want to use the crosshair points. We want to get different lattice points. Now, we're able to get additional lattice points when we have a radius that is the hypotenuse of a Pythagorean triple. So it works when your radius is the hypotenuse equals the radius. The hypotenuse of the Pythagorean triple equals the radius. And then I like to say that the other terms that I'm given, the 5 and 12, are pretty much directions. Directions to help me arrive at my lattice points, my additional lattice points. So remember, these are 4 crosshairs are lattice points, but I want 8 more, so 8 additional lattice points. Now, these are directions from the center. So I'm going to start with one thing. We're going to start by saying, let's move 5 to the right and then go 12 up. So if I start here, I can move, watch, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up. Now, if I do that, I go 5 to the right, 12 up. Now, this works because I can form this right triangle where 13, which is the hypotenuse, would be the same as the radius of my circle. Now, how do I find this point right here, this point right there? Well, let's think about it. From the center, I went 5 to the right. Well, if my center is negative 5, 3. If I went 5 to the right, that means if I add 5 to negative 5, that's 0, and then I went 12 up. So I add 12 to 3, which is 15. That is 1 point. Now I can use that same logic. Instead, I can go 5 to the right, and I can go 12 down. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, I can make a right triangle where the hypotenuse is the radius. So see, and this works because I have 13 as the radius and the hypotenuse. Now, if I think about that, I went 5 to the right. So again, I added 5 to my x value. So that would be 0. And then instead of adding 12, I'm going to subtract 12 from my y value because I went down. 3 minus 12, in this case, what we're going to say is -9. So I have 2 lattice points. Now I can draw the same right triangles in the opposite direction towards the left. I can go 1, 2, 3, 4, 5 to the left, and I can go 12 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 12 down. So I went 12 up, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 down. And again, you can see that if I draw these right triangles, the hypotenuse corresponds with the radius of 13. Now, if I think about this, I'm going 5 to the left. So instead of adding 5 to my x value, I'm subtracting. -5 minus 5 is -10. I went 12 up. 13 plus 12 is 15. Then I went to -10 again, and then I went 12 down. 3 minus 12 is -9. So I have 4 lattice points from that one that triangle being like kind of reflected a couple times. Now, I said 8 additional ones. Well, the reason I'm saying 8 is because I can also rearrange the triangle, that 5, 12, 13 triangle. I can rearrange it another way to still have 13 as a radius. So, for example, instead of going, let me pick a different color. Instead of going, in this case, instead of going right 5, I'm going to go right 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 5. 1, 2, 3, 4, 5. So that should be my circle. Might not be great because I did it rough hand. So this should be on the circle because I have a hypotenuse of 13. Same here. I can go down 5. 1, 2, 3, 4, 5. So right there, and I have a hypotenuse of 13. So now what differs here is what I'm adding. If I'm adding 12, I'm going to the right, I'm adding 12 to the x value. So -7 plus 12 would be, -5 plus 12 is 7. So I am going 7. So I went 7, then I'm going up 5. If I go up 5, 3 plus 5 is 8. 3 minus 5 would be -2. So I have 2, those are the 2 points here, you know, by using just rearranging my 5, 12, 13 triangle. Now again, last ones will go in the opposite direction. So I'm going to go 12 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 5. 1, 2, 3, 4, 5. Go down 5. 1, 2, 3, 4, 5. And remember, my circle might not be perfect because I did it I did it freehand. All right, guys, so this is it. So now these 2 points have to be on my circle. So this one I see, I'm going to have to expand my circle a little because I didn't hit my point. That's okay. And so when I take a look at this, all right, guys, now I take a look at this, I went left. So I subtracted 12. I said if I go left, I subtract from my x. -5 minus 12 is -17. I go up 5. 3 plus 5 is 8. Then I go left 12, which again is -17. Then I go down 5. 3 minus 5 is -2. All right. So now I have 8 additional lattice points. So I have 8 additional lattice points using these, in this case, 8 additional triangles. All right. And this only works when we have the hypotenuse of your Pythagorean triple is equivalent to your radius. And again, lattice points. Lattice points are points that have integer values for x and y. So your 4 crosshairs are lattice points. However, here they're aiming for find 8 different lattice points, just to emphasize what a lattice point is. All right, your homework is attached below. If you have any questions, please visit me during campus conference. You're going to have just a take-home graded assignment on Monday, just going over this stuff on circles. And if you have additional questions, please let me know. If you have questions and you want to answer and you can't go to the conference, you can send me an email, or we can set up someone that suggested maybe a Google Doc where you can write down the questions and I can make videos about how to go over them. All right. But if you do have a question and I don't have the doc ready, I'm looking for it for next week, please just send me an email and I can go over any problems needed. All right. All right, guys. Have a good day.